Namaste dosto. Imagine holding an ice cream cone in your hand. That familiar shape, wide and round at the bottom and tapering smoothly to a point at the top, is called a right circular cone. So, what exactly makes it a right circular cone? Well, it's because the vertex, or the pointed tip, is exactly above the center of the circular base, forming a perfect right angle with it. Now, to understand this cone fully, we focus on three important measurements. First, the radius, which we call r. This is the distance from the center to the edge of the base circle. Then, the height, h, which is the straight line distance from the base's center up to the tip. And lastly, the slant height, L, which is the length along the cone's side, from the base edge right up to the vertex. These three are related by the Pythagorean theorem. L squared equals r squared plus h squared. Or in words, L squared equals r squared plus h squared. This shape is not just a math figure. It appears everywhere around us. Ice cream cones, conical tents pitched at fairs, even funnel-shaped pipes used in kitchens and labs. Before we dive into any formulas, it's super important to know what these parameters mean and how this shape is put together. Imagine a diagram here with the cone labeled neatly with its radius r, height h, and slant height L, so you can picture each part clearly. Ready to explore the volume of this cone? Let's go! Okay, friends, now that we've met our cone, let's talk about volume. What is volume? Simply put, volume tells us how much space a 3D object takes up. It's like asking, how much water can I fill inside this container? Volume is always measured in cubic units like cubic centimeters or cubic meters. Now here's a cool fact about cones. If you imagine placing the cone perfectly inside a cylinder that has the same base radius and the same height, the cone takes up exactly 1/3 of the cylinder's volume. Yes, just 1/3. Visualize this. A cylinder with a circular base and straight sides, and inside it, your cone tapering towards the top. So a cone is kind of a slimmer, tapering version of that cylinder. In our imagined diagram, you'd see the cone fitting neatly inside the cylinder. And that relationship between cones and cylinders is key to understanding the cone's volume formula. Curious how 1/3 comes into play? Hold tight. Next, we will look at the formula itself. Let's now write down the formula to find the volume of a right circular cone. Imagine the radius is r and the height is h. Then, the volume, which we call V, is given by V equals 1/3 times pi times r squared times h. Let me say that slowly again. Volume equals 1/3 multiplied by pi, multiplied by the square of the radius, then multiplied by the height. This formula means that the volume of a cone is exactly 1/3 of the volume of a cylinder with the same base radius and height. That's no coincidence. It comes from mathematical ideas like integration or by rearranging solids, which show that three identical cones fit perfectly inside one such cylinder. Notice how both r and h are part of the formula. That's because the cone is symmetric around its height axis. Imagine spinning it around the vertical line passing through the tip and base center. One caveat. This formula works only for right circular cones, where the apex is directly above the base center at a right angle. If the cone leans over, what we call an oblique cone, this formula doesn't hold because the height isn't aligned straight. Picture our cone again labeled with r and h, and the formula floating alongside. Keep this handy. We'll use it soon for a numerical example. Ready for some math magic? Let's understand why the volume formula for a cone works by slicing the cone into very thin circular discs stacked along its height. Imagine the cone stands upright along the z-axis with height h. We slice it horizontally into super thin discs, each having a tiny thickness dist. At height z above the base, the radius of that particular disc is r of z. Because of similarity of triangles in the cone, the radius at height z is proportional to z. We say r of z equals r divided by h times z, or the radius at height z equals the total base radius multiplied by the fraction z over h. The area of each disk is the area of a circle. A of z equals pi times r of z squared, which becomes pi times rz over h squared. Now to get the total volume, we added the volumes of all these tiny disks by integrating from z equals 0 to z equals h. V equals the integral from 0 to h of a of z dist, which is pi times r squared over h squared times the integral of z squared dist from 0 to h. Calculating the integral of z squared gives us h cubed over 3. So substituting in, v equals pi times r squared over h squared times h cubed divided by 3. Simplifying, h squared cancels with h cubed, leaving us with v equals 1/3 times pi times r squared times h. There you have it, a neat calculus proof confirming the volume formula derived earlier by geometric reasoning. Imagine a diagram here showing the cone formed by stacked disks with radius changing from 0 at the tip to r at the base. Amazing, right? Now, let's try a quick example to apply the formula. Suppose we have a right circular cone whose radius r is 3 centimeters and height h is 4 centimeters. What's its volume? We use the formula v equals 1/3 times pi times r squared times h. Step 1. Radius squared is 3 squared, which is 9. Step 2. Multiply 9 by the height, 4, giving 36. Step 3. Multiply 36 by 1/3, getting 12. So, the volume is 12 times pi cubic centimeters. That's V equals 12 pi cubic centimeters. If you like decimal answers, pi is approximately 3.14. So, 12 times 3.14 equals approximately 37.70 cubic centimeters. Imagine the cone with the radius and height labeled, and this solution neatly boxed next to it. Great job if you followed along. This kind of problem is super common in exams, so make sure you write each step clearly. To wrap up, let's quickly recall the key points. First, our main formula. Volume B equals 1/3 times pi times r squared times h. Remember, the slant height L relates to r and h by L squared equals r squared plus h squared, which helps with surface area calculations but indirectly connects here. Key ideas to keep in mind. The volume of a right circular cone is exactly 1/3 of the volume of a cylinder with the same base radius and height. We can derive this either geometrically or using calculus, by integrating thin slices or comparing solid volumes. Importantly, this volume formula applies only to right circular cones where the vertex is directly above the base center. For oblique cones, the volume calculation is different. And one more practical note, always use consistent units. If the radius is in centimeters and height also in centimeters, your volume will come out in cubic centimeters. Arey wah! Now you know how to find the volume of a cone both intuitively and rigorously. Keep practicing these ideas and you'll master all questions on cones. Ready for a quick mental check? If the radius doubles but the height remains the same, does the volume double? Think about it. Yes, since volume depends on radius squared, doubling r makes volume 4 times bigger. Excellent beta. Keep up the great work.